No, school up on holidays, but we still have to run in on the plantation. We see Csec youth some have exam Thursday. So we have to just come in, come put in some extra work, I think set up. The struggle is real, but what? Still have to try the way for the done. So one of them things there. 50. So it's basically saying every meter across the land you walk, the land rises 50 meters. So the heat from the earth will warm the air. See? What happened to warm air? It rises. So the warm air is rising, and we call that process convection. Now, as the warm air rises, the air and the sea is cooler. So the cooler air now rush in to fill the space. So you have wind. See? So the cooler air from the sea rush in to fill the space of the warm air that is rising. In the day in the night now, the land cools down very quickly, while the sea is now warm. Out at sea now, warm air is rising. Our heat is leaving, so it's calling the air above it to warm and rise. As the warm air rises now, cooler air from the land do what? Rush in to fill the space. So the land, the wind now is now blowing from the land to the sea at night, which in the day was blowing from the sea to the land. So remember, look up at the question, it says explain why air flows down high mountains at night. Because remember, if the mountain is high, it means the temperature lower. Cool. So the cooler air from the mountain and from the land now is rushing down the mountain and flowing to the sea to replace the warm air that is rising. Simple as possible. We could start at subduction zones are created at a convergent plate boundary when an ocean and a continental plate collide, right? And it says your diagram. So remember, so you have your continental plate here. Then you have your oceanic plate. So then along the continental plate now you may also have this occurring somewhere here. Out there, so you might have the earth starting to buckle and then resulting in folding, right? So here, where the oceanic plate starts to be forced into the mantle below, the continental plate is the first. Now when I read this, they have the sea trench, and here you have your subduction zone. Alright? The edge of the plate here, so, is melting. This area here is the mantle. Alright? So you have now melted material going up through weaknesses in the crust to form a volcano there. And because compression is occurring here as two plates collide, the continental plate, which is less dense, part of it starts to buckle and then and is uplifted and forced upwards to form full mountain. See? It's a, how many marks to the question? 4 marks. Then the diagram is not finished until the bar right? And you type it. Diagram showing what it said? The main features of a extrusive and intrusive volcanic features, and give one example of each. First thing first, so you have intrusive features. Inside. Exterior, outside. So intrusive volcanic features are features that are formed under the Earth's surface, within the crust. When what? Magma cools and hardens. Extrusive volcanic features are formed When magma reaches the Earth's surface, it becomes lava, cools and hardens. If it is intrusive, we have 4 of them. Sills, dikes, lactoliths, batholiths. Extrusive features we have volcanoes, we have lava plateau. Describe 2 ways, explain how earthquakes are formed at the transform plate boundaries. First thing I'm going to tell the markers is what's a transform plate boundary. Transform plate boundary occur when 2 plates move in opposite direction, slide past each other. Yeah? So we have plate A here, we have plate B here. Plate A is going in that direction, plate B is going in this direction. But the plates are not smooth, so what they do, they rub against each other. So at the zone of interaction, which is the plate margin or plate boundary, right? So they rub against each other. As they rub against each other, they may become stuck. So this plate is going this way, this one is going this way. So what is going to happen if they become stuck? Pressure will be generated. Over time, the pressure becomes so great that eventually it snaps, generating vibrations or shock waves, causing the earth to shake, resulting in an earthquake. Next question says, I know you're going to label a diagram and then something, the title of the diagram. Using an example, account for the formation of fold mountains where continental plates collide. So make it a diagram first. So if we say collide, we're talking about convergent plate boundaries. So we have a plate again. The plates are moving towards each other. But if we say continental plate, so this is a continental plate. I know continental plate are called sialic plate, silicon and aluminum. Both of them are of the same density. None of them are heavier than each other, none of them are denser than each other. So we call this area of interaction or plate boundary, but because it's 2 continental plates, it forms a collision zone. If it was an oceanic and continental plate, subduction zone of the form. So as the plates collide, compression, so the plate is doing this. One is going that way, one is going this way. So when they meet up, it's just like 2 cars in the same lane. Eventually when they collide, what happens to the bonnet of the cars? They will be forced upwards on. So as the plates collide, none of them is heavier, none of them is denser, so no subduction taking place. So the end of the plate start to buckle and bend, and eventually they are forced upwards and they fold to create the formation of a fold mountain. For this example, you have another example. You have the Himalayas, where you have the Indo-Australian. No, miss. And Eurasian plates colliding. See, you have the Alps, where you have the Eurasians, and the African plates colliding. So those are prime examples where you have collision zone resulting in the formation of fold mountains. Next question says, explain how lava plateaus are formed. In order for that to occur, more than likely you need divergent plate boundaries. Yeah? So this is what is happening here. The plates are being ripped apart here. See? Remember the plates rest on the mantle. So when the Earth's crust is being torn apart, material from the mantle comes up through that space, and because pressure is being released, and you more than likely will have basic lava, the lava spreads out. Instead you have a violent eruption. But more and more lava comes out and it spreads out. So it starts to accumulate. Over time, it accumulates to form an area elevation when the lava cools with a relatively flat top to form a lava plateau. So as one plate move away from the other, material from the mantle here, so you have the mantle. So magma comes up here, when it reaches the surface, you know it becomes lava, right? Chances are it will be basic lava, so it's very thin, it's very fluid, so it flows over very wide here. As it flows out, it starts to accumulate and cools. It cools and hardens to give rise to an area of elevation with a flat top. But when you want in nature, anywhere we have areas of elevation or highland with a flat top, we call it plateau. But because this one was formed by lava coming to the surface, we call it a lava plateau. It is also called a basalt plateau, because remember the other name for basic lava is what kind of lava? Basaltic lava. Next question now, we're done with that question. It says, draw a label diagram to show the main features of a dendritic drainage pattern. First thing first, we know that drainage has to do with how water is removed from the land, or how water flows into rivers, right? So first thing you need a main stream. We call that stream a subsequent stream. Then now you will have smaller streams. What is the name for other smaller streams that join larger streams? Tributaries joining the main stream. See? What is the junction where one stream joins another? What we call that junction? See one here, see one there, one there, and one there. What we call them places? Call it a confluence. So we have the area that this river is draining along with its tributaries. And all the area in here that the river is being drained, that the river is draining is called the drainage basin. The area that separates this drainage basin from another one, which is a line here, we call it a watershed or divide. No, the question says, because what you're trying to do is try to maximize the marks as best as possible. So the question says, draw a label diagram to show the main feature of a dendritic drainage pattern. So yes, we have a confluence. That is not necessarily a main feature, but what we need to pay attention to first is we have our main stream here. Then we have smaller streams that join, we call them tributaries. But what we need to pay attention to now is that the tributaries are joining other tributaries and the main stream at angles less than 90 degrees. So when you look at it now, the tributaries, when they join the main stream, gives the drainage pattern the appearance of a, so it's tree-like in appearance. And the next thing, there are many surface streams. Why? Because the underlying rocks tend to be uniform and impermeable. So what is happening now? Most of the water remains on the surface, so you don't have any underground stream because it's still on the surface. You have many surface streams and the tributaries tend to join the main stream at angle less than 90 degrees. So you type here that a hill or a mountain. Down here, so now we would have probably a one channel. We would have some plants here, so we would have probably the sea out there. So the diagram now will be like the art class. Yeah, just make sure it's accurate. So we have the most important part of the cycle here. So this is critical. So we have the sun here, right? So energy from the sun now hits the land, hits the water, hits the plants. Causes the plants to lose water in the process here of transpiration, right? The water now, some of the water is converted into a gas. And this now is evaporation, yeah? The gas now rises. As it rises, and some of the water that was lost from the plant is also converted into a gas. So as it rises now, the higher up you go, the cooler it gets. So the gas can no longer remain, and gas is converted into water droplets in the process of condensation. Correct? Good? So the water droplets start to form and they start to accumulate around each other. And they form what? They form clouds. See? The clouds now becomes larger and larger and heavier till they reach a point where they can hold no more moisture, so the clouds become saturated. So we still have some clouds over here. The clouds over here, so now, when the gravity starts to act on them and pull whatever moisture, it will form as snowflakes. And you have snow over here on the mountain. But here now, it is not as cool as over here, so the precipitation is in the form of rainfall. So we have precipitation occurring. See? When the water hits the plants, it slows down the flow of water, we call that interception. But we're not right. Eventually now, the water hits the land, some of it will flow over the surface, we call that runoff or overland flow. Eventually it enters back the rivers and the streams. Some of the water enters the soil in infiltration. Some of it goes down vertically through the soil in percolation, and we can go on and on and on and on and on and on and on. Talk about through flow and ground flow and all of them stuff there. Water being stored in aquifers and them something, eventually it comes back and the process continues. 4 months, 24 years, 2.5 hours standard. It says, describe 2 characteristics of limestone which makes it susceptible to chemical weathering. We know that weathering is the process where rocks attacking the earth's surface are broken down. Yeah? You have 3 types of weathering. You have physical weathering, is also called mechanical weathering. That is where rocks are broken down into smaller fragments. So the physical size of the rock is changing, and it's physical weathering. You have chemical weathering now, where the mineral composition and makeup of the rocks are altered or changed. In order for that to happen, more than likely you need this here. Water. So whether it is hydration, oxidation, carbonation, solution, or hydrolysis, whichever the process is occurring, they need water. But we're talking about limestone now. We know that limestone is a type of sedimentary rocks. It's made up of sediments which were compacted over time. It's also made up in layers. See, we know that now limestone is a type of rock that allows water to pass through. So we say it's what? What is the name we give to the ability of any form of solid that allows water to pass through? It is permeable. See? So one, remember what the question is saying, it says describe 2 characteristics. So one, you're going to tell them that limestone is permeable. Permeable means they allow water to pass through. Why they allow water to pass through? Because in the rocks they have small holes and spaces, we call them pore spaces, that allows water to pass through. In the rock as well they have vertical cracks and joints that allows water to pass through. So this makes the rock porous, this makes the rock pervious. So permeability now, water can pass through. If water can pass through, it will alter the rock. Next thing, limestone is made up predominantly of calcium carbonate. CaCO3. See, calcium carbonate is a soluble mineral. Soluble means that if it comes in contact with water, water is able to dissolve the mineral. See? So watch this now. If it is made up predominantly of calcium carbonate, and calcium carbonate is a soluble mineral, it means that when water enters the rock, the water will do what to the calcium carbonate? Dissolve it and remove it. If you remove it, the building block of the rock, what will happen to the rock? It will become weaker. So over time, that rock will break down. So 2 things, permeability and the fact that it is made up of calcium carbonate. My next question says, we just look at limestone and we say it is a sedimentary rock. It is made up of layers and then something. See? Rock pillars, in order for rock pillars to form, first you must have a cave. So what I would suggest to you is, even though caves is at the bottom there and the three things on this, you talk about that first. Or you even have to talk about cave first. You can talk about the sinkhole first. So you start on the surface, then you move subsurface. So I'm going to talk about the sinkhole first. So sinkholes are also called swallow holes, and they are formed when limestone rocks are weathered, causing streams or rivers to disappear underground. See? Remember I said that limestone rocks are perfect, so they have cracks and joints. Done. So if they have cracks and joints now, rainwater over time will absorb carbon dioxide from the atmosphere. When it absorbs carbon dioxide from the atmosphere from the soil, it forms a weak carbonic acid. When that weak carbonic acid hits the limestone rocks now, it will dissolve the calcium carbonate, leaving behind calcium bicarbonate, carrying the calcium carbonate away. So the calcium carbonate is carried away in the water right now. I will soon come back to it. In solution. So the cracks and joints becomes bigger and bigger over time till they form a vertical hole in the ground through which, so you will have no. So the river was flowing here, all along. See? So the river was flowing along here, all along. But what will happen now, as this area becomes larger and larger, the river starts to do what now? Flows down the vertical joint here. And it will go underground. When it goes underground now, the water will continue to erode material underground. So it will start to erode areas underground, start to open up here. See? As it does that now, you have caverns that are formed. Those caverns become larger and larger over time to form what? To form caves. See? So on the surface here, it's the same way. Remember the river used to flow up here. See? So the river is not flowing up here anymore, so we have what we call a dry path. See? However now, what will happen is that rainwater is still absorbing carbon dioxide. So some of the rainwater start to percolate down through these rocks. Eventually it reaches the top of the cave. See, when it reaches the top of the cave now, the water drips from the top of the cave, leaving behind slender needle-shaped formation that we call stalactites. Some of the water drips on the floor of the cave now, creating deposits of calcium carbonate that are shorter and stouter than the slender needle-shape. But over time, the stalagmite on the ground starts to grow large, and the stalagmites in the roof start to extend further downward. Eventually what will happen is that these two things will join and the rock pillar is formed.
Remember to like, share, subscribe. This is Steve saying until next time, walk good.